This video is brought to you by the CBM Program Studio cross-compiler for the Commodore family of computers. If you're a fan of this toolset, and you should be, please remember to help support its continuing development by making a generous donation using Arthur Jordison's PayPal link on the download page. Your donation will grant you priority bug fixes, new beta versions, and Arthur's eternal gratitude. The Merriam-Webster dictionary defines a maze as a confusing, intricate network of passages. The term is also synonymous with labyrinth. I've always been fascinated with mazes, so much so in the early 90s I picked up this book which contains all kinds of crazy mazes. Having said that, I thought it would be fun to create a video covering programming mazes. In this video I cover the process of creating a random maze using the recursive backtracker algorithm in Commodore BASIC, assembly language, and for the first time I also try porting the Commodore BASIC program over to INTYbasic, utilizing a little bit of what I learned from the Programming Games for Intellivision book. I started out writing my own version of a backtracker algorithm in BASIC and was struggling a little bit when I came across this website. I just decided to go ahead and start with the program presented here and adapt it to my needs. For those of you interested in the recursive backtracker algorithm, I recommend you check out these terrific YouTube videos to learn all about it in more depth. Links in the description. Alright, this is the original maze program that I copied from the rosettacode.com. It was line by line copied, except I added these comments at the beginning. And I wanted to demonstrate that running. So I'm within CBM Program Studio, I'm going to press F5. And you see it says initializing, building, and it's so slow. But eventually it draws a maze. And I think it's slower because the maze width initially is 10 by 10. So right there. The maze size, but you can see this is real time as it goes, and I could warp it using the emulator, but I want to just show how slow this is. And then it draws, and so there's your maze. Now you can kind of play around with just different paths through it, but that's the way this maze draws. So this version that I copied straight from rosettacode.org has these three-dimensioned arrays, one for the south walls, one for the west walls, and one for the visits. And then it also has an array for the stack, one for the rows and one for the columns. And what I didn't want to have three different maze variables, so I only wanted to use the visit array and then the stack array. I didn't want the south and west wall array, so I decided to restructure the code just a little bit to eliminate those. So in my first cut, I eliminated those two other arrays, the south wall and the west wall. And then rather than building using those arrays, I just poked and rather than printing out the maze at the end, I just decided to use a poke command to build the maze as it progressed. So as it builds the visits, I build the borders, and as it builds the visits, I poke the values onto the screen, and then the resultant output, you can kind of watch it as it goes. And then I further refined it a little bit better in my final adaptation right here. I optimized it a little more, and on this one I have the width. You can see I have a width of 18 and a height of 11, and let's run it. And I just like watching these things go, kind of build the array. This backtracking algorithm is pretty neat how it works. And I'm going to speed it up using the warp. Okay, so I had it change colors when it was finished, and I think at the end down here I just go to itself, so it loops forever. So it's really neat. It draws a neat little maze. You could either use I guess you use the blue characters as your maze walls, And then what I decided to do from here was to go ahead and translate this into assembly language. And that took quite a while. I decided to use this version of the program right here since it was a little more optimized and cleaner than the original, and I like the way it pokes onto the screen. And that turned into this assembly program. So I have a constant for the width and the height. I have a constant for the background character. Near the top here, I initialize all the variables. That way, when you can run the program a second time after it runs, I draw the first couple of starting characters, draw the maze border, and then I draw the whole maze. And I'm excited to hit F5 to run that for you here in CBM Program Studio. And I didn't, you have to assist it. Oh, I changed the background character and I went large here. And right now it ends. While on the subject of the width and height, you might say, why is the max width 20 when you have a resolution of 40 characters going across? Well, one thing you have to understand is when you're developing a maze program like this is that you have to have a space for the wall and then one space for the space to move through the maze. And so that takes up half of your resolution. So, and it works both for the horizontal and for the vertical space. If you switch this to 160, I wanted to see what it looked like with that other character. And I went on the max width too. So it draws a different maze every time, theoretically. Yeah. And so when I just run it, every time you assist it, it runs it. And you can play around with the width and height, and it's still slow, but it's not as slow as in BASIC. It's not instantaneous like you would think. So let's make this like 15 by 10, make it a little smaller, so you can actually see that the border's being drawn in. So there you have it. There's the maze in assembly language. This was fun. This was a fun little program to write. It took a while, what you don't see in the making of. I didn't put all the coding that I did to get this working. But I did have, it did not work on the first try, of course. I failed miserably. A couple of things I wanted to point out in the program. I do have a few macros. And I have I've talked about this before in other videos where you can do a region. And when there's a region, you can use the plus and minus to eliminate or to hide that section of code. So if you don't want to see the program macros and you want to look what's above and what's below, you can set a region using this command, and then at the bottom of the region, do end region. And then I have these macros like this poke AXY and peek AXY, and that just pokes a value onto the screen using whatever is in the accumulator at position X, comma Y. So X characters over horizontally, and then Y characters down vertically. Same thing for the visit array. I decided, you know what, that's really all this is a glorified array. So I use the same construct for the peek, for the visit, poke, and peek for the visit array for AX and Y. So when I'm putting values into the visits to keep track of what positions have been visited. And then I did a small macro here to add values. So what it does is it takes the first two parameters, in this case X, comma X, and then stores it, adds them together and stores it in the third parameter. So when you see these add YY, comma screen Y, it's adding Y to itself. It's doubling the value in this particular example. And then down here I have my program variable space. I have a stack, the stack just like in the basic program, and I have my visit array. And then I discovered a command in the CBM Program Studio called DCB. I don't know what that stands for, but it zeroes out. So if you do DCB 256,0, it zeroes out 256 bytes. I thought that was useful for when you first start out. You don't have to, when you're first writing the program, you don't have to initialize your variables. You can just have that, and they'll already be pre-initialized. And then finally, I did a check here to make sure that you have a valid x and y, or really it should say width and height. So to make sure that the program basically doesn't run properly, or you'll get unpredictable results if you go outside of the values here that are listed. So you can go 3 to 20 on the width, or you can go 3 to 13 on the height. Any smaller or any larger, and some weird things happen. And so anyway, and then it just returns out of the program. It doesn't tell you. So that is the assembly language. And this was a fun program to write and optimize. And once I finally got it running, it was exciting. Like, oh, cool, check it out. And finally, after some careful consideration, I decided to port the BASIC program into INTYbasic. Using the book that I just purchased, Programming Games for the Intellivision by Oscar Toledo G, which is a terrific book. I highly recommend if you want to get into programming for the Intellivision. It's a really, really good book to learn to program on the Intellivision. I tried to do it as closely as I could to the BASIC program, the optimized BASIC program that I modified and tweaked. There's a few important differences to note on the Intellivision BASIC language versus the Commodore BASIC language, and I wanted to talk about that. The first difference is the resolution. On the Commodore 64, the screen resolution is 320 by 200, which is broken up into 40 by 25. So 40 columns across by 25 rows of characters. On the Intellivision, the resolution is 159 by 96 pixels, which is broken into 20 by 12 cards. The next kind of challenge that I had to deal with in order to port my maze program was the lack of two-dimensional array support. This was not a huge deal, but it did make things more difficult. For example, in Commodore 64 BASIC, you can have a variable like visits in parens y comma x, and simply use y and x and y variables to address it. On the Intellivision BASIC, you have to emulate the two-dimensionality by having a single array and using multiplication and addition to accomplish the same task. Also on the Intellivision, you are restricted with the amount of memory and the number of variables you can use, which can come into play on a larger project. On the other hand, the Intellivision has many positives that I wish the Commodore 64 BASIC had. It has no line numbers, it supports labels and more modern language constructs such as while and when. It supports if then else. You can use line separators. It supports include files. It's more tightly integrated with assembly language. And Oscar has even built in commands to easily support the controller and to play music. But here is the actual program. Now I'm going to run it. So there it is. There it is, drawing the maze. Let's see. Right now I have it, the maze is beyond the width of the screen a little bit, so I could tweak the size to make it a little smaller. Right now it's 10 by 6. I can make it, let's say, 8 by 6. And try it out. And oh, let's go 8 by 5. So you can see the border. Let's just run it multiple times so you can see. Here's one version of the maze. That's another version. Let's run it again. And there's, oh, it kind of looks like this, the first one. I did notice I was having problems with randomness a little bit, trying to get this thing to generate a different random maze. And that's why this press up is in there. So what I'm doing is I have a loop where it says press up, and it's generating a random number. And until you hit press up, then it seems to make the randomize work a little better. And let's take a look at the program. I do have a command. I love this language. It's so eloquent. I don't know if that's the right word, but I do have a check here for the border. So if it's greater than, these parameters right here, then it says invalid maze params, and it exits the program. And it's so easy to do that little loop I was talking about. While the controller.up is false, generate a random number. Just kind of go in an endless loop. And then so it does that until I press up. And actually on the emulator, I'm just hitting up arrow on the keyboard to accomplish that. And then I have a variable for the character that's drawn onto the screen, and really this is just this is the actual character. The first 2 byte or 5F times 8 is the card, and then the +6 at the end is the color of the maze or the wall. And while on this subject, Oscar Toledo G had sent me this website link, which has the GROM picture catalog, which is actually really useful. So you can see in my program code, I am using 5F, so 0, 1, 2, 3, 4, 5 down, and then all the way over A, B, C, D, E, F. So it's using the full character, and that's the card that I am using on the Intellivision. So you can kind of select through whichever GROM picture card you would like to use in your program. And you can see the whole program just about. I guess you can't quite see it. I'll have to make this scroll. There. I have the stack array I changed it to SX and SY for the stack X and the stack Y, and stores the positions of every position that's drawn on the screen. And then of every visit, I guess. And then it has a visit array. And then it's similar to the Commodore 64, it has a poke and peek command. So but rather than having the 2-dimensional visit array, I'm having to use a single dimensional array, and I just do a multiplication to accomplish that. So it's almost the same program here as the basic program. If I switch back to CBM, so here's the basic program for CBM Program Studio. You can see the loop here for the border, and then I think one of them is, those are the vertical border, and then this one's the horizontal part of the border. And then right here, is the main meat of the program, where it pops the stack, pushes the stack, and sets the visits and pokes onto the screen. So it's the same thing in INTYbasic here. And this took a while to get working. What you're seeing here is the fruit of my labor, getting this to work right. And it was actually this is my first attack at doing a program here on the Intellivision, other than the sample one I did from Oscar's book, his terrific book. And then up at the top here, I didn't know how to quit the program when you have invalid maze parameters. So I didn't I tried end, I think I tried quit, and it didn't work. So I just did a go to the bottom here to go to the exit program, and that seems to work. And let's try a few different values. Let's try 5 by 5. Anyway, I don't claim that these programs are 100% bug-free, but I'll put them up on my GitHub, and anybody who wants to go out there and download and play around is welcome to do so. And I had fun tinkering and trying to figure out this maze program. Out of the 3, I like the assembly for the Commodore 64. I like that version the best. I guess more because the resolution is so much greater, so you can have more characters across and down, and the maze looks more realistic due to that fact. So, but I do like the language, the INTYbasic, and I wish there was something a little more like that on the Commodore 64. Maybe there is, I just don't know about it. But the built-in Commodore 64. I really wish that language was more like this rather than having to put in the line numbers and all that. Because of the great job Oscar Toledo G has done with this language and the book, there's going to be a lot more people programming games for the Intellivision. We're already starting to see the fruits of that, with INTYbasic games getting official releases, such as Super Minefield, for example. There's also a lot of great examples in the INTYbasic Showcase Volumes 1 and 2. So I've noticed a lot of people are out there writing great programs here for the Intellivision thanks to Oscar Toledo G. Anyway, thanks for watching, and go create yourself some mazes.